Hi, this is Hilal. In this video, we will optimize a multivariable function and checking the second order condition using HESSIAN method. So the question is, optimize z is equal to 3x square minus xy plus 2y square minus 4x minus 7y plus 12. Use HESSIAN to check second order condition. So we have to check second order condition using HESSIAN. Now first of all, the condition is for a multivariable function to be at optimum, or there are two conditions. First is called the first order condition. The first order condition states that the first order partial derivatives of this multivariable function should be equal to 0 simultaneously. So first of all, we take the first order partial derivatives of this function. That is first order condition is given by the partial derivatives first, with respect to x and y should be equal to 0 simultaneously. So that is the first will be then Zx. That means differentiating partially this multivariable function with respect to x. Now this is here 3 2s are 6 x minus, here it will be the derivative of my x is here 1, so this is minus y, since no x is involved, so it is here 0. Here minus 4x, the derivative of 4x is 4, so I will write minus 4. Here no x's are involved, so it is 0. Now zx is equal to 6x minus 4 minus y minus 4, and we set it equal to 0. Similarly, second is z of y, partially differentiating the given multivariable function with respect to y and set it also equal to 0. Now here no y is involved, here it is minus x plus 4y, since no y is involved, so it is here 0. Here it is minus 7, since here no y is involved, so it is also 0 here, the derivative of 12, and set it equal to 0. So this is the first order condition, that is the partial derivatives of the given multivariable function should be equal to 0 simultaneously. That is, we have to find the critical values. Now we have to solve these two linear equations to get the optimal value of x and y. Let this be equation first and let this be equation second. So we are with these two set of equations. Now how to solve these? What will we do? We will make the coefficients of any x's or y's same in both equations. So we can make this x as actually 6. That is, we multiply second equation by 6. That is multiplying equation second by 6. So this will become minus 6x plus 6 4s are 24 y minus 7 6s are 42 is equal to 0. Let this be equation third. Now we will add equation first and third to get rid of this 6x and 6x. This will get cancelled. That is adding equation first and third. So we get now 6x minus 6x, which is equal to 0. Here minus y plus 24y, that is 23y. Here minus 4 and minus 42 is minus 46 actually. This is minus 46 and set it equal to 0. Now this is equal to y is equal to 46 divided by 23, which is equal to 2. So we got the value of y is equal to 2, implies y is equal to 2. We put y is equal to 2 in either of the two equations, first two equations. We put y is equal to 2 in first equation to get the value of x, that is 6x minus, in place of y we write 2 minus 4 is equal to 0. Now solving this will become 6x minus 6. 6x minus 6 is equal to 0. implies x is equal to 6 divided by 6, which is equal to 1. That means the value of x is 1. So we got the critical points, that is x is equal to 1 and y is equal to 2. So this was the first order condition. Now we have to check the second order condition. To check the second order condition, we form a Hessian matrix. That is to check second order condition, we form a matrix which is composed of all the second order derivatives of the given multivariable function. That is formed by, that is we write H is equal to, so H is a matrix which is composed of all the second order partial derivatives of the given multivariable function. The first derivative is Zxx, second is Zxy, third is Zyx, and fourth one is Zyy. Now these are the second order derivatives of the given multivariable function. So we can see here, I will write here, now Zxx, the second derivative, means we have to differentiate this partially with respect to x again. So this will become Zxx becomes, here it is 6, so this is here 6. Now Zxy, xy means differentiating this first equation with respect to y now. So here it is -1. Similarly zyx means differentiating this second equation with respect to x. So it is here -1. So I will write here it is -1. And zyy means differentiating this equation with respect to y now. So this is here 4. Zyy is 4. So our matrix becomes H is equal to, now Zxx is 6, Zxy is -1, Zyx is -1 here, and Zyy is 4. So this Hessian matrix is composed of all the second order partial derivatives with second order direct partials on this axis, this principal axis, and second order cross partials on non-principal axis. These Zxx and Zyy are second order direct partials, and this Zyx and Zxy are second order cross partials. So we formed here this Hessian. Now the condition is, what we have to do, we take the first principal minor, that is our first principal minor is, that is first principal minor is denoted by H1. Now the first principal minor is always the first element. Here Zxx is the first principal minor, which is here 6, which is equal to 6, and here it is greater than 0, it is greater than 0. And second principal minor, that is H2. H2 is the second principal minor. The second principal minor is composed of all these 4 elements. That is, the second principal minor is 6 minus 1, 6 minus 1, minus 1, and 4. Now solving this, which is equal to, now 6 4s are 24, minus 1 1s are 1, minus 1 into minus 1 is plus 1. So it is here 1. Now 24 minus 1 is 23. So our H2 is also, which is equal to 23, which is also greater than 0. Since here H1 is greater than 0, H2 is also greater than 0. When h1 and h2 are both greater than 0, we say that h, which is I will write HESSIAN, which is denoted by h, is positive definite. Positive definite, and Z is minimized at critical values. That is, when the value of h1 is greater than 0 and h2 is also greater than 0, in that case HESSIAN, this h is called positive definite, and Z is minimized at critical values. Now suppose if this h1 was less than 0, if this h1 was, let us say it was minus 6, it was less than 0, and h2 was greater than 0, at that time we could have said that the HESSIAN is negative definite and Z is maximized at critical values. So when h1 is greater than 0 and h2 is also greater than 0, Z is minimized. When h1 is less than 0 and h2 is greater than 0, at that time we say Z is maximized at critical points. So I have already covered the concept of HESSIAN and checking the second order condition in earlier video. You can check that out also.